So we finished off with 18a. Let's move on to 18b right here. And again, the instructions are to rewrite it as a logarithmic equation. Okay, so let's say you're confused, like I explained on part A. If you're confused about an exponential to a logarithmic, do a logarithm that you already know. Okay, like for example, log base 2 of 8 equals 3. Everybody should know that one. Log base 2 of 8 equals 3. Because the base of the logarithm will be the base of your exponent situation. And you always think 2 to what power gives me 8, right? That's how it works. The base on the logarithm becomes the base on the exponent situation. And then 2 to what power gives me 8? Well, 2 to the third power gives me 8. That's why the answer is 3. So the 3 goes up there on the exponent. So once you do a simple logarithm that you know how to do, then you could just look at where the numbers go. The base on the logarithm becomes the base on the exponential equation. Or you could go from the exponent back. So if this is the base on the exponent, put the base on the logarithm. See how the answer's over here? That's going to be right there. And this answer, or the exponent, becomes the answer. So it's just a question of rearranging things, right? There it is with color, so you guys could see where they go. The base goes, or the base goes there, the answer goes there, and this exponent becomes the answer. So B is, again, the base here will be the base on your logarithm. So we have log base 25. Log base 25 of what? Well, remember the answer 8 became this, and the exponent became the answer. So the exponent is going to become the answer. And of course, the only thing left is the 5 that we need to put right here. So there's your answer right there. Log base 25 of 5 equals 1/2. Once you do the rearranging, then you could even think about it. Is it true that 25 to what power gives you 5? 25 to the 1/2 power gives you 5. Because remember, the 1/2 power is a square root. So I hope this helps. Do a simple one, and then see how it rearranges. The exponent becomes the answer. The base is always the base, and then you could see that the 8 has to go there if the exponent was the answer. Number 19, solving logarithmic inequalities. How easy is that? Well, you simply cancel out the logs, right? Because technically you could raise both sides to be the power of base 5. You don't even have to show that work. You just cancel them out. That's only if you have the same exact logarithm. Log base 5, log base 5. Yeah, cancel them out. Okay, so what do we have left? We have the new inequality. 7x plus 3 is greater than or equal to 5x plus 17. Let's move the 5x over to the other side by subtracting it. It's going to cancel, subtract it. You're going to get 2x plus 3 is greater than or equal to 17. And then, of course, we're going to subtract 3 to get rid of the 3. And we're going to end up with 2x is greater than or equal to 14, which means that your final answer, x, when you divide by 2 on both sides, x is greater than or equal to 7. That is one answer. After that, you have to go back to the inside of the logarithms, and remember that you can't have a negative value on the inside of the logarithms, kind of like you can't have a negative value inside a square root. So we have to set those inside values to be greater than or equal to 0. So there we have both of those values set greater than or equal to 0. So on this first one, let's, subtract 3 on both sides. You're going to have 7x greater than or equal to negative 3. Of course, we're going to divide by 7. So we have x is greater than or equal to negative 3/7. And then we jump to the third one. And let's subtract 17. So we have 5x plus, 5x is greater than or equal to negative 17, and then we divide by 5, divide by 5. Final answer will be x is greater than or equal to negative 17 over 5, which is, 3 2/7, negative 3 2/7. So what we do now is take all 3 answers, put them on a number line, and then test where the solutions are going to be at. So let's go down here to a number line. 7 positive over here, negative 3/7. That's close to 0. And negative 3 2/7. That one's over here, negative 3 2/7. So let's test values. So like, let's say we tested a value that's further left on this side of the number line. So if we tested something like negative 5 and plugged it in right here, 7 times negative 5 is negative 35. Negative 35 plus 3 is a negative 32. You can't do a log of a negative. It'll say error. So obviously over here it does not work. You could test a value that's between, let's say, negative 3/7 and negative 3 2/7, maybe like negative 3. Again, if you did plug in a negative 3 right here, that'd be negative 21. And that would give you a negative value in there, because negative 21 plus 3 is still negative 18. So that can't work either. So let's say this can't work either. So let's jump over here to this inside value. Like, let's say 0. 0 is right here, so let's plug in 0. 0 plus 7, 0 times 7, 0 plus 3. You could do this, the logarithm of 3. Log base 5 at 3. It'll be an irrational decimal, but you could still do it. Plug in 0 right here also, because 0 plus 17 is 17. You could do a log of 17. So this right here does work. Let's try a value that's greater than 7. Like, let's say 10, for example. If you plug in 10, that's 70 plus 3 is 73. You could do that. Plug in 10, 50 plus 17, you could do that. So it looks like your answers are right here and here. So how to represent that in terms of those inequalities, I would say that you simply represent all that as negative 3/7 greater than or equal to. So the only answer is this guy. It's unnecessary to write this guy, because when you say greater than or equal to, it's already going that way forever. So in other words, out of these 3 answers that we got, the only single answer that represents this whole inequality is the middle one. X is greater than or equal to negative 3/7, because right here, going that way, is where our area of answers are. So on number 20, you have to use the properties of logarithms to condense it. These are the 3 properties that we've gone over in the past. The product property is when you have like log, or you know what, let me go with ln, because it's a little easier to write, less space. Ln of x plus ln of 2. Well, if you have a plus sign and you have both the same type of logs, and ln is the same type of log, it's log base e on both of them, then you could put them together, but you have to multiply your x and your 2. So you could write them together as ln of 2x. That's condensing with the product property. The quotient property is the same thing. That's where you have something like ln, let me use a and b, ln of a minus ln of b, and you could condense that, and all you have to do is put the a over b. Quotient means division, so that's really going to be ln of a over b, ln of a over b. And the power property, that one's easy also. That's when you have like, let's say log base a, but let's say you had a times b out in the front, like a b out here in the front times b. Well, then what you could do is you could take this b that's out here in the front, whatever number is being multiplied out in the front, you could put it as an exponent of that a value right there. So let's say b times common log a, or b times ln of a, could become common log of a to the b power. Okay, so those are the 3 properties. That's what we're going to have to apply on number 20. So what we're going to do is the product property. Because of this plus sign, we know we're going to be able to condense both this log base 4 and that log base 4 as one single log base 4. Okay. The only thing is, when you condense like that, you have to multiply your whatever you're taking the log of and whatever you're taking the log of. So right there is going to get a little interesting because it is a binomial times a binomial. So we have x plus 2 times x minus 2. Okay, so this is what condensing with the product property looks like. You take both log base 4s up here and you put them as one single log base 4 down there, and this x plus 2 and that x minus 2, you put them together with multiplication. So let's distribute. Let me zoom in a bit. Let's distribute x times x squared, x times negative 2, negative 2x, 2 times x, positive 2x, 2 times negative 2, negative 4, and of course the middle terms cancel out because one's positive and one's negative. So what we really have here on the left side is log base 4 of, in parentheses, x squared minus 4. Let's take a look at the other side of this equation. It's not an inequality. We have a 2 over there. So let's bring down the equal sign and, whoop, that's an ugly equal sign, and the 2 right there. Okay, so we have this new logarithmic equation. It has a single logarithm instead of 2 of them. And let's get rid of this log base 4. Remember, the inverse of a logarithm is an exponent situation. So to undo a logarithm, we have to raise it to become the exponent of base 4. So we're going to go base 4 here, base 4 over here, because what you do to one side, you do to the other. Log 4 to the log base 4 cancels out. The x squared minus 4 comes down. The equal sign also comes down. And 4 squared is 16. So at this point, I notice that there's a quadratic, right? It's x squared. Now, if there was another x right here, or if this 16 were an x, if I had an x squared and an x, I would move everything to one side, set it equal to 0, and try to factor, split, and solve, or at the very least, always be able to fall back on the quadratic formula. However, there's only one variable here in this whole equation. This is not a 4x, it's not a 16x. So what does that mean? There's only one variable. You could isolate the variable. So instead of factoring, splitting, and solving, or instead of the quadratic formula, you might as well just solve it like any Algebra 1 problem. Isolate it. Plus 4 cancels, plus 4, and you are going to get x squared. Let me move this over. X squared equals 20. So we're going to have x squared equals 20. Now this is an equation, and we are going to apply a square root to both sides, which means you're going to get x equals plus or minus. Now the square root of 20, you don't get a nice, beautiful answer. You have to actually simplify that. So let me go up here and write down the square root of 20 and think of a perfect square number that I could break it down to with multiplication. And obviously that'll be 4 times 5. And then you split the root. The square root of 4 is 2, and the square root of 5 comes down. So you have 2 square root of 5 as your final answer. So x equals plus or minus 2 square root of 5. So you guys could practice with part B. I'll leave that to you. And I want to end the video here. There's not much time to move on to 21. We'll pick up on 21 on the next video.